hope you like my new intro there. Anyway, welcome to my Unity movement tutorial. Here I'll show you two ways which I usually prefer to do my movement using the rigid body velocity and the rigid body add force. I'll also show you the math behind movement using vectors and how the different methods I'm using for the movements affects how your game will eventually work. Without further ado, let's get right into the video. Right here I got an empty Unity project in which I want to place a little template. I'll place a plane right here, reset its transform, and I want to scale it up to like 5 times because it's quite big. I have downloaded a package which gives me some prototype materials. I leave a link to this package in the description if you want to use it for yourself. I'm just gonna make the plane right here, and I'll create a capsule. Set the Y position to 1, and boom. I'm gonna also give him an orange material. This guy is gonna be a player. Since I'm just covering movement, I don't really want to make a camera script. That's kind of relevant, but I'm gonna make a top view for the camera. Just set the Y position to 10 and make it look directly down on a little player right here. Then I'll create a quick folder for my scripts. This is just a habit of mine. In here, I'll make my first C# script called the player movement. Alright, in here, I'll find some variables which I want to use. I want to have a public variable which holds a rigid body, and I'm also going to add an attribute called require component, where I can define a type of component I do want to have on the game object with the script on it. It also says right here, the require component attribute automatically adds required components as dependencies, which just means that the player movement script is going to be dependent on the rigid body, therefore it makes sense to add it as an attribute. Then I'm also going to have a float called speed, which is going to be the speed of a character. I'm also going to make something called a header attribute, which is going to be something in the Unity inspector, which will hold some variables. It's going to hold a X and Z input. And then I'm going to have my vector3 variable called movement. Great. Right here in my void update, I want to define my input and place inside these two variables, X input and Z input. With the Z input, X input, I'm gonna set that equals to the input dot get access raw, and in here I'm gonna write horizontal. The input access raw returns a float, and this float is gonna be a value which is defined by your A and D keys. The way I know I need to write horizontal is because this is something in Unity's very own input access manager. If you want to find that for yourself, you can click on Edit, Project Settings, Input Manager, and open up for the axis. Right here, I have found the horizontal, which holds for the A and D buttons. Over here, we also have vertical, which you guess it, is going to be the next input axis, which we're going to use because it holds the S and W keys. So for the Z input, I'm now going to write input.getAxis vertical. Now we're going to store these inside of a movement vector. Anyway, the movement we're going to define by using the transform dot right axis, this is going to be the direct axis of the transform inside the world space. What that means, this little arrow right here, this is the transform.right. It is the right side relative to this object's rotation. If I move the Y rotation, you can see the red moves, and this is still going to be the right side relative to our game object. So that's what I'm going to use. And then I'm going to times it by the X input. Then I'm going to also add the transform.forward and times it by the Z input. And this is great. Now, technically this will work and we have a movement input. But this is not done yet. The problem is, as I'm going to show you right here, if I print the movement of magnitude and I start my game, I am going to print the magnitude, which is the length of the vector. Right now, I'm holding A, which is going to print 1. But when I hold both A and, for example, W, it's going to print over 1, which is bad. That basically is a 40% increase in our speed. And the way of this is because vector's length is calculated by using Pythagoras. But Unity, of course, has a solution for this, and that is to use the movement.normalize. This function is going to take the length of a vector and set it equals to 1. So it's going to be 1 no matter what direction it is facing, which is what we want. Then we can times a movement by a speed value using the speed equals shortcut. And that's basically it. Now, for our starters, I'm going to use the rb.velocity to represent the movement, since this is the easier to set up. The rp.velocity is going to directly set the velocity of this rigid body and change its speed. So if I set my speed to 5, our player will then move 5 meters per second. Then, just because I need some visualization of this, I'm gonna draw some gizmos. I'm gonna set the color of this gizmos to yellow. And then I want to draw a simple ray, which is gonna show you the direction this is gonna face. This is then gonna face the rp.velocity. We're then gonna set the direction to the movement dot normalized and times it by the rb.velocity dot magnitude. And this is it. Now I'll go and start the game, and then you can see what has happened. I have forgot something. Alright, everything works. We're gonna set the speed to 5. Also, make sure you have the gizmos turned on when you're gonna play the game, and take the 3D icons, things like this, and just set it to 0. When we can press play, and now you can see our character move. So what you see now is that we have something called the instant input. Instant input is basically going to take the input we have and directly set it to the velocity of this rigid body, which is nice if you want to have some instant input. Preferably I like instant input because that means I have total freedom of whatever else I want to do. But let's say you want to smooth things out a little bit. Also, by the way, you can also take the void and use a fixed void update and use this for the actual movement. The reason for this is we kind of want to move in a fixed frame rate instead of using the void update, which is called upon every frame, and that's gonna take like with delta seconds, like the difference in milliseconds per frame, do some calculations. It's gonna fluctuate in the void update. In the fixed update, or RB velocity is gonna remain constant. Well, anyway, if you want to smooth things out, the easiest way to do this using the RP velocity is to take this get axis raw and just remove the raw. The get axis raw by default will apply a smoothing filter across the input, which I'm going to show what it looks like right now. Which is cool, but it also only works when you try to change the direction one key per time. Let's say I skip a key like this. You can see it's kind of snappy, but other than that, it's totally fine. And you also get the instant input when you want to go in the complete other direction. So this is one way of smoothing, and this is only using the RP velocity. The next thing I'm going to show you is going to use the rp.addForce. The rp.addForce is going to apply the force upon the widget body, which is going to be based on the movement. We kind of want to modify this a little bit, and by that we don't want to apply the speed here. We can do that, but I like to do the speed calculation inside the addForce. We're just going to normalize it right here. Then this speed variable is now going to act as a form of force, maybe speed force. And we're going to have force mode and set it equals to the force on objects. The force as a continuous force on the object using X mass. You also have another type called acceleration. And acceleration just accelerate the rigid body, ignoring X mass. I kind of like using the mass in force, so this is what I'm going to use. So as you see right here, now this object is getting a continuous force added to it, which is technically really smooth. Like it's kind of flowy, but you can of course modify this because yeah, right now you're probably thinking that the RP velocity is way better to use, but that's because you don't modify this enough. There is some things you can do. First thing is that you can actually clamp your velocity. So we can say that rb.velocity is equal to a vector3.clamp, clamp magnitude. Then we're just gonna put in a rb.velocity, which is the vector3, and then we can give it a max length, which is the maximum speed we can have. And we can set that to, for example, 5. You can also add with the speed force. Usually you can have a pretty big variable now because we have set a limit to how fast we can go. Like now we can have a continuous change of like 25. And as you see right here, it is more smooth. And this is something you can play with. If you want to make your Alfonso more snappy, again, we can just play with this. I can also like set speed force to 80. Which actually looks quite nice. Another thing, when you use the add force, something I can usually recommend is we're gonna set the get axis back to raw because we don't want the input actually to have a smoothing filter because the add force is kind of like a smoothing filter. So we want the instant input but we then combine it with the adfault, which is going to be really smooth. And yeah, this looks pretty good. You can apply with the friction and make it slow down first, but if you like it as it is, then it's great. It is something you can play with and try and have some fun with, but which is basically just a simple guide on how to make this actually work. And I hope you kind of learned something. If you already knew how to make movement, then I don't know why you watched this video, but maybe you learned on how to draw gizmos. Anyway, this is a really quick movement tutorial. I don't really have a lot of time to make more lengthy tutorials because I'm having an exam soon, but after the exam I plan on to make a tower defense, since a lot of people in my class are starting a tower defense course, and I kind of want to help them. Anyway, this is it for my tutorial, and I hope you liked it. If you did like it, please subscribe, that would be nice. I'm trying to get to, I don't know, 25 subscribers, is pretty cool. Anyway, goodbye.